Cationic polymer drug carriers have the advantages of good stability, low immunogenicity, and fast preparation and modification. Here we offer a rapid and simple method for its synthesis. Reversible addition-fragmentation chain transfer polymerization method is a method applicable to yield block polymers with controlled molecular weight and structure and carrying functional groups.
These drug carriers can simultaneously carry different drugs to achieve the cooperative treatment of cancer, inflammation, and other diseases.
RAFT polymerization is a classic method, and this protocol gives an example of its application in gene therapy.
The key to the successful synthesis of this polymer is to precisely control the reaction temperature. It is more advisable to use an oil bath than a water bath.
To begin this procedure, obtain a round-bottom flask with a rubber stopper and a magnetic stirrer to be used as the polymerization bottle. Dissolve 1.87 grams of bis-hydroxyhema in 1 milliliter of distilled water in the polymerization bottle. In a 5 milliliter beaker, dissolve 0.03 grams of CTP and 0.02 grams of ACVA in 0.5 milliliters of 1,4-dioxane. Add this mixture to the polymerization bottle. Then, use a condensate trap to freeze the solution in the polymerization bottle. Fix the bottle to the iron support and use a conduit tripped with a needle to vacuumize and inject nitrogen into